Next, problems based on partial fraction expansion method. So here we are solving the numericals where we consider different cases depending on the nature of the poles. So here first case is when there are simple poles. So in that first problem, obtain inverse Laplace transform of equation given is xs is equal to s minus 1 by 2 divided by s square plus 3 by 4 s plus 1 by 8, and here ROC is minus 1 by 4. It is sigma greater than minus 1 by 4. So here solution for this. So first we will obtain the roots or the poles of denominator term. So x of s is equal to s minus 1 by 2s divided by s plus 1 by 2 s plus 1 by 4. Now step 1 is so here step first is in partial fraction expansion we can write equation of x as in partial fraction expansion we can write equation of x of s as x of s is equal to a1 by s minus p1 plus a2 by s minus p2. So here p1 is equal to minus half and p2 is equal to minus 1 by 4. So therefore x of s is equal to a1 by s plus half plus a2 divided by s plus 1 by 4. Now we calculate the coefficients of a1 and a2. We write here calculate coefficients of a1 and a2. So now we have a of k is equal to s minus pk into x of s. So s is equal to pk. Therefore a1 is equal to s minus p1 into x of s at s is equal to pole p1. So therefore a1 is equal to s plus half minus 1. We already know that how to calculate this coefficient. So it is s minus half, s plus half, s plus 1 by 4 at s is equal to minus half. So we calculate it. a1 is equal to minus 1 divided by minus half plus 1 by 4. So it is minus 1 by minus 1/4, it is 4. So this is the value of a1. Now we have to calculate value of a2. So a2 is equal to s plus 1 by 4 into s minus half divided by s plus half into s plus 1 by 4 at s is equal to minus 1 by 4. Therefore a2 is equal to minus 1 by 4 minus half divided by minus 1 by 4 minus becomes plus. So it is minus 3 by 4, 1 by 4, it is minus 3. Now we substitute these a1 and a2 values in above equation and we get x of s is equal to 4 by s plus half minus 3 by s plus 1 by 4. Now next is step 2. Now what is step 2? Step 2 is pole 0 plot and given ROC. So we draw here pole 0 plot. First we write here both the poles, here both poles are negative, sorry, here pole value is negative, so it is on the left side of the ROC. Both poles are to the left side of ROC. Therefore, both terms correspond to right-handed signal, that is multiplied by u of t. In bracket we can write multiply by u of t. So equation is x of t, so we can write here, therefore x of t is equal to Laplace inverse of x of s. So it is Laplace inverse of 4 by s plus 1 by 2 minus Laplace inverse of 3 by s plus 1 by 4. Here we draw the diagram for this, that is ROC. So it is sigma, it is j omega. So it is, this pole is P1 minus half, it is P2 minus 1 by 4. We denote it by this cross. So we'll draw here a dotted line, okay, and here the ROC is sigma greater than minus 1 by 4. Now we have a standard Laplace transform pair. So we write here standard Laplace transform pair is e raised to minus at u of t. The standard Laplace transform pair is 1 by s plus a, where for this ROC is sigma greater than minus a. Now we can write, that means Laplace inverse of 1 by s plus a is e raised to minus at u of t. Now for this ROC is sigma greater than minus a. Therefore Laplace inverse of 4 by s plus half is 4 of e raised to minus 1 by 2t u of t, and Laplace inverse of 3 by s plus 1 by 4 is 3 into e raised to minus 1 by 4t u of t. So therefore x of t is equal to, combine it, 4 e raised to minus half t u of t minus 3 to minus 1 by 4t u of t. This is the final answer. Now next problem. Second problem. Find the inverse Laplace transform of x of s is equal to 3s plus 7 divided by s square minus 2s minus 3. So first step 1. Here degree of numerator is less than denominator, so equation is in proper form. We write here degree of numerator is less than denominator, so equation is in proper form. Next is step 2. Now the roots of denominator. Roots of denominator is p1 is equal to 3 and p2 is equal to minus 1. Therefore, x of s is equal to 3s plus 7 divided by s minus 3 and s plus 1. Next is step 3. In partial fraction expansion form, we can write x of s is equal to a1 by s minus 3 plus a2 by s plus 1. Now here we have to calculate the values of the coefficient a1 and a2. So we calculate it. Therefore, here a1 is equal to s minus 3 into 3s plus 7 divided by s minus 3 s plus 1 at s is equal to 3. So we substitute these values. 9 plus 7 by 3 plus 1, it is 4. So value of coefficient a1 is 4 and value of coefficient a2 is s plus 1 into 3s plus 7 divided by s minus 3 s plus 1 at s is equal to minus 1. So we calculate this value as it is minus 3 plus 7 minus 1 minus 3, it is minus 1. So we can write this equation as xs is equal to 4 by s minus 3 plus, not plus minus, minus 1 by s plus 1. Now next is step 4. Step 4 is so we consider a casual sequence and inverse Laplace transform. We write here considering casual sequence and inverse Laplace transform is x of t is equal to 4 e raised to 3t u of t minus 1 e raised to minus t u of t. Now next problem. If x of s is equal to minus 2 by s plus 1 plus 4 by s plus 2 and ROC for this is s is in between minus 2 and minus 1, then find x of t which is inverse Laplace of x of s. So first we write down the given equation. So what is given? Given is x of s is equal to minus 2 by s plus 1 plus 4 by s plus 2. For that ROC is in s is in between minus 2 and minus 1. Now this equation is already in the form of partial fraction. Okay, we write here this equation is already in the form of partial fraction expansion. So poles here P1 is minus 1 and P2 is minus 2. Now we'll draw for these poles minus 1 and minus 2. So it is sigma, it is j omega, it is minus 1 pole, and this is minus 2 pole. This is region of convergence. So pole is denoted by this cross sign. Now inverse Laplace of the given expression. Inverse Laplace of given equation is x of t is equal to Laplace inverse of x of s, which is equal to Laplace inverse of minus 2 by s plus 1 plus Laplace inverse of 4 by s plus 2. Now here we consider only the first term, and here pole is s is equal to minus 1. So what we are considering here, we consider only the first term, and in the first term the pole value is minus 1. Now from this figure the pole is to the pole is to the right side of the ROC. This is ROC, and the pole minus 1 is to the right side of the ROC. So corresponding to this term, the left-handed is there is a left-handed sequence. That means it is multiplied by u of minus t. Now we have standard Laplace transform pair. As minus of e raised to minus at u of t. Its Laplace transform is 1 by s plus a for sigma less than minus a. So we can write Laplace inverse of 1 by s plus a is minus e raised to minus at u of minus t. Now we consider second term, that is 4 by s plus so here the term is minus 2 by s plus 1, that is Laplace inverse of minus 2 by s plus 1 is, it is minus of minus 2 e raised to minus t u of minus t. So we can write it as 2 e raised to minus t u of minus t. Now we consider second term, that is Laplace transform 4 by s plus 2. Now here pole is left side of the ROC. Here is ROC, and the pole is left side of the ROC. So corresponding to the time domain term is right-handed sequence, that is it is multiplied by u of t. So now we have standard Laplace transform pair. It is standard Laplace transform pair is e raised to minus at u of t. Its Laplace transform 1 by s plus a for sigma greater than minus a. Therefore Laplace inverse of 1 by s plus a is e raised to minus at u of t. So we can write above equation as 4 by s plus 2. It is 4 into e raised to minus 2t u of t. So Laplace inverse of given sequences, we combine all this, both this term. Laplace inverse of given sequence is x of t is equal to 2 e raised to minus t u of minus t plus 4 e raised to minus 2t u of t. So this is the answer. Now next problem. Next problem, find the inverse Laplace transform of inverse Laplace transform of x of s is equal to 2 by s plus 4 s minus 1. So if region of convergence is first region of convergence is, it is minus 4 less than res, and second one res of less than greater than 1. So first we write down the given equation. So given equation is x of s is equal to 2 divided by s plus 4 s minus 1. Now in partial fraction expansion form, we can write x of s is equal to a1 by s plus 4 plus a2 by s minus 1. So a1 is equal to s plus 4 into 2 by s plus 4 into s minus 1. So it is s is equal to minus 4. Therefore a1 is equal to 2 by minus 4 minus 1 minus 2 by 5, and a2 is equal to s minus 1 2 by s plus 4 s minus 1. So s is equal to 1. Therefore value of a2 is 2 by 1 plus 4, that is 2 by 5. So now we have values of coefficients a1 and a2. We substitute these values. Therefore x of s is equal to a1 value is minus 2 by 5 divided by s plus 4, and a2 value is plus 2 by 5 divided by s minus 1. Now we have this equation. Now we have to apply the two convergence region of convergence. So the first one is ROC is, it is minus 4 RE of s 1. Therefore above equation becomes x of t is equal to minus 2 by 5 e raised to minus 4t u of t minus 2 by 5 e raised to plus t u of minus t. And the second one is region of convergence is u of s greater than 1. So we can write x of t is equal to minus 2 by 5 e raised to minus 4t u of t minus t plus 2 by 5 e raised to t u of t. This problem was asked in exam for 6 marks. Now next problem. Find inverse Laplace transform of x of s is equal to 3s plus 7 divided by s square minus 2s minus 3 for first condition s greater than 3, second s less than minus 1, and third condition s is in between minus 1 and 3. So first is step 1. Now here the degree of numerator is less than denominator, so equation is in proper form. We write here degree of numerator is less than denominator, so equation is in proper form. Now next is step 2. So step 2 is roots of denominator. So roots of denominator are p1 is equal to 3 and p2 is equal to minus 1. Therefore x of s is equal to 3s plus 7 divided by s minus 3 s plus 1. Now next is step 3, that is in partial fraction form. So we write here in partial fraction expansion form x of s is equal to a1 by s minus 3 plus a2 by s plus 1. Now we have to find the values of a1 and a2 coefficient here. So first we calculate a1, it is s minus 3 3s plus 7 divided by s minus 3 s plus 1. So it is s is equal to 3. So we substitute these values here and we get a1 as a 4. Next we have to calculate a2. So a2 is s plus 1 into 3s plus 7 divided by s minus 3 s plus 1. So it is s is equal to minus 1. So it is minus 3 plus 7 minus 1 minus 3, it is minus 1. Now we substitute these values of coefficient, that is values of a1 and a2 in above equation. So equation become, therefore x of s is equal to 4 by s minus 3 minus 1 by s plus 1. Now we consider a casual sequence inverse Laplace. So we write here considering casual sequence exponential sequence, inverse Laplace is x of t is equal to 4 e raised to 3t u of t minus 1 e raised to minus t u of t. So the first one is first condition is s greater than 3. Therefore x of t is equal to e raised to minus at u of t into e u of t. Then second condition is s less than minus 1. Therefore x of t is equal to minus e raised to minus 3t u of minus t plus e raised to t u of t. And the third condition is s is in between 3 and minus 1. So x of t is equal to is to minus 3t u of t plus e raised to t u of minus t. So this problem was asked in exam for 7 mark. In this way we can solve this problem. Now next problem. Determine inverse Laplace transform of function is x of s is equal to 2 divided by s into s plus 1 and s plus 2. So first we write down the given equation. So given equation is xs is equal to 2 by s into s plus 1 s plus 2. So we have to use partial fraction expansion form here. So we can write this equation in the form of it is equal to a1 by s plus a2 by s plus 1 plus a3 by s plus 2. Now we have to calculate here values of a1, a2 and a3. So a1 is equal to 2 by s plus 1 s plus 2 at s is equal to 0. So its value is 1. Next we have to calculate a2. So it is 2 by s into s plus 2 at s is equal to minus 1. So we solve this and we get at s is equal to minus 1 we get a2 is equal to minus 2. And third one a3 is equal to 2 by at s is equal to minus 2. So we get this value as 1. Now we substitute these a1, a2, a3 values in the above equation. So therefore x of s is equal to 1 by s minus 2 by s plus 1 plus 1 by s plus 2. Now we have standard Laplace transform pairs. We have standard Laplace transform pairs as u of t is 1 by s and e raised to minus at u of t is 1 by s plus a. So by using this standard pair we can write the equation inverse x of t is u of t 1 by s inverse Laplace is u of t minus 2 e raised to minus t u of t plus 1 e raised to minus 2t u of t. So this problem was asked in exam for 7 mark. Next problem, find inverse Laplace transform of x of s is equal to minus 5s minus 7 by s plus 1. Okay, the equation is in the form of xs is equal to minus 5s minus 7 divided by s plus 1, s minus 1 and s plus 2. So this is given equation. Now in partial fraction expansion we can write this equation as xs is equal to a1 by s plus 1 plus a2 by s minus 1 plus a3 by s plus 2. So we have to calculate the values of a1, a2 and a3 here. So a1 is minus 5s minus 7 divided by at s is equal to minus 1. So this value is 1. Similarly, if we calculate values of a2, it is s plus 1, s plus 2 at s is equal to 1. So this value of a2 is minus 2. Similarly, a3 as minus 5s minus 7, s plus 1, s minus 1 at s is equal to minus 2. So this value is 1. Now we substitute this a1, a2, a3 values in this equation and we get, therefore x of s is equal to 1 by s plus 1 minus 2 by s minus 1 plus 1 by s plus 2. And we have standard Laplace transform pair. So by using this, or we can say taking inverse Laplace by using standard formula. So x of t is e raised to minus t u of t minus 2 e raised to t u of t plus e raised to minus 2t u of t. So this problem was also asked for 7 mark in the university exam. So in this way we can find out the inverse Laplace transform of different equations.